Hey guys, welcome to the final part of this build, or at least what I hope to be the final part of this build. I've got the GPU, I've got the block, I've got everything to finish this build, and there's gonna be a lot of things in this video because I need to get the water block on, I've got to finish the rest of the tubing, and then fill the loop, test it out, boot it up, install Windows on RAID 0, and then hopefully I can get some temperatures and power draw figures or whatever just to see how everything works with this. So there's a lot of things to do. Let's get it. First up, I just want to comment on how large the 3090 is. As you can see here, it's just as tall as the chassis itself. And in fact, it is basically the same size as the 280 millimeter radiator back here. The thickness is about right. The height is just about the same, and the width is just about the same as the 280 millimeter radiator. In fact, it is, I'm almost positive it is bigger than a 240 millimeter radiator. So, in fact, if I just line this up for you guys here, give me one moment. How insane is this? The entire fan structure, this thing is hanging off the edge of the chassis, and being 3 slots, it's actually not slotted in right now, but being 3 slots, it's basically, the level is just about a couple millimeters below the PCIe slot. So it would just about clear it if I had kept the original shroud, but that's not a problem because I've got this right here, and this water block is gonna be chopping this part off of the graphics card because the PCB is only this long. The disassembly of the graphics card isn't actually all that difficult. It's actually relatively straightforward. It's only a very unique form factor. All you need to do is to remove the 4 plastic tabs that are held in with a magnet with a piece of tape. And then you've got a V-shaped bracket that you just pry out, and then you got 4 screws underneath that. And then you remove the 4 Torx screws that's holding in the backplate. From there, just remove the 3 wires that's held in by black little tabs, and then take out the leaf spring CPU bracket held in by the 4 screws. The back plate also comes out, or the IO shield also comes out by a few screws, and from there just clean up the thermal pads and thermal paste off of the core. And lastly, you've got a bunch of thermal pads from EK that you put on the components per the manual and assemble it together with the water block. However, I ran into a little issue where I ended up stripping out this screw, the Torx screw. I don't know how I managed to do that. It was just most likely a poor screw that went in. So I had a little bit of difficulty here. And that's how you drill out a screw. I really don't recommend doing this, especially on such an expensive GPU, but I am out of ideas, so hopefully that worked. And would you look at that? I managed to drill that screw out so the top came off and that back plate was able to be removed. All right, it's been a long time coming, but the system is finally mechanically complete, meaning all the runs are in and the water is also in. The GPU here was the centerpiece, best choice piece of equipment for this build because as you can see, the 3090, it's not super long anymore. It's perfect for the size. And I was waiting for this 3090 FE and I just couldn't get my hands on it. Any other 3090 doesn't have the shorts PCB. It had to be the FE because of the size. And this computer is so over the top because I've got a 3090 here and I've got a 5960X 16 core CPU, and it is just all in this little teeny tiny form factor. It's crazy. I didn't really bother with leak testing. It seems like these days I just don't bother with leak testing. If it leaks, it leaks. And especially since, well, I mean, I guess I would just live on the edge a little bit. But in any case, it looks like everything is fine. There's no leaks. This run right here, this was a nightmare because it's got two bends, one bend right here, one bend right here. You kind of lose all your degrees of freedom. Meaning if this bend is off by a millimeter here, or if this angle is off by a little bit, or if the apex of this bend is off by just a little bit, that piece is scrapped. So I think I probably went through 3 meters worth of tubing, so 9 feet worth of tubing just to get this little teeny tiny 6-inch piece of tube right. You know, bending tubing is kind of difficult. You think metal should be malleable and whatever, but it is. But being very thick stainless steel tubing, it's just, if it's not bent right, it's not bent right, and you're not gonna be able to bend it with your hands. You've gotta use the tool. So let's talk about what I've done here. So what I've got is the cable that comes from the down below. I think this is a very clean run. And instead of coming up from behind, looping around, it just comes straight in from the power supply. So that is a good choice. I did add this piece right here, and it happened to be perfect that the angle coming out or the height coming out goes straight into the GPU, 90 degrees in. And then this right here, I thought about coming over and around. I thought about coming under and around. I kind of decided on a compromise where coming down and then slanted up, because coming straight around, it kind of overlaps with this fitting right here, and it just really gets, you know, it almost looks like it wraps around and it's just too busy here. So that's why I wanted to come from down below. But down below, I didn't want something coming straight up and something coming straight up again. So that's why you got that 45 in there. I think it looks great. It breaks it up a little bit, but keeps it interesting. And I want to say that the water cooling part of the front, this is the centerpiece of this bend right here. I feel like is the centerpiece. Maybe I'm biased just because I spent so long on it, but when you look at it, it's like, oh, this is kind of interesting, and then oh, this is kind of interesting, and then you see the rest of the system, because the stainless steel tube kind of just pops. So I got it all filled up. I've got it powered on. Of course, I haven't actually really tested it. I know it powers on because the lights, you know, power on. So that's a good sign at least. I'm gonna go connect it to the monitor. I'm gonna go ahead and install Windows on this right here. This is RAID 0 980 Pro. So I've got 2 terabytes, 1 terabytes, I don't know how many. I think it's actually two 2 terabyte M.2 SSDs, 980 Pros. So it's gonna be blazing fast. It's gonna be great. And I'm gonna go install Windows, and then I will catch you guys on the performance tests or the thermal tests. All right, I've got everything installed and everything's up and running. You can see behind me, I've got Unigine Heaven running, and it's been running for a while now. And I've got both the pump speed and the fans tuned in. So the pump's running about 40 to 50%, and the fans are running anywhere from 300 RPM to 900 RPMs. And all right, I actually should back up and talk about the specs, because it's been a while since I filmed part 1, and most likely you've already forgot by now. So it's got a 5960X 16-core CPU with a 3090 FE GPU, water-cooled on a 280 millimeter radiator, 45 millimeters thick. And I've got 280 or 140 millimeter fans, 2 of them, blowing anywhere from 300 to 900 RPM. So we're keeping it quiet, basically silent if possible. So with all that said, I'm not going for super good temperatures. I'm just going for bearable temperatures, being silent. And with those settings, Heaven Unigine running, I'm seeing about 15.8 to 15.9 degrees Celsius on the GPU. So the GPU is boosting up to right around 2000 megahertz, pulling 400 watts. And then of course you got the CPU dumping heat about 120 or so watts into the loop. From the power meter here, we can see that we are currently pulling 570 watts from the wall. 95% efficiency, let's just say. This whole system is using about 500 or so watts, which kind of makes sense because 400 watts going to the GPU, but 100 watts going to the CPU, that's about 500 watts. So clearly the 750 watt power supply is fine. I've got a headroom of another 200 watts to be able to pull if I don't know, if some extreme overclocking or whatever happens, but as it is right now, it is not an issue. Now, temperature wise, like I said, GPU is at 59, right now 59 degrees Celsius. CPU is, actually I don't know what the CPU is, but it's currently clocking at 4.7 to 4.8 gigahertz on all, not all cores, but boosting to 4.7 to 4.8 gigahertz. I have chosen not to do a all-core boost because overall you get a lower overclock than if you let a few cores boost a little higher. So on games, you don't use all 16 cores, so you only use 2 or 3 cores heavily, so it's better to just let those cores boost. You know, overall, I see the temperatures are fine. Actually, let me go right around the back and double check the temperature of the water. So currently, I know you guys can't see this, but the water temperature is 43 degrees Celsius and the fan speed is sitting at 917 RPMs. So, and you can feel a lot of the heat coming out from the back. And then there you go, the AC is kicking on because it's just dumping out heat. 43 degrees Celsius on the water, that's really warm. Ideally, I guess the set point is right around 35 degrees Celsius and it ramps up the fan. I've put a hard limit at 900 RPMs. If I let this go all the way to 1200, I think these fans go up to 1250 RPMs, right? It gets pretty loud. And I can drop that 43 degrees Celsius water to right around 37 or 38 degrees Celsius. So clearly 280 millimeter radiator is doing its job for about 500 watts, but the delta on ambient being 20, what is it, 22, 23 degrees Celsius in this room. Water's at 43 degrees Celsius, so that's about a 20 degree delta on water. That's a little bit higher than the normal 10 degree delta on water, but hey, it really doesn't matter to me if the water runs a little toasty, even, you know, especially under gaming loads. In other words, I would much rather run a 20 degree delta on the water than have to deal with fan noise when I'm gaming. So that's just my personal opinion. You know, you can run whatever fan profile you want, whatever makes you happy on temperature. As I said, even though I'm pulling 60 degrees Celsius constant, this boost is still better than on air, even though I'm not getting, you know, full boost. I could potentially boost a little higher if I were to drop the temperatures, but because it's on water and it's plateaued right around 60 degrees, 59, 60 degrees Celsius, the boost is constant. So I'm, you know, constantly boosted right at or under 2 gigahertz. So for me, water cooling is all about constant boost, silence, and just overall performance reliability. And that's essentially what I'm getting right now. So all in all, I think the build turned out really good. As you can see, a little bit too RGB at the moment. I haven't dialed in the LEDs or whatever. I haven't decided if I want a solid color or if I want to rotate on RGBs. This currently is a little bright. I would like to turn this down a little bit, get that nice glow, you know, even it out a little bit. But in any case, that's just fine tuning of the RGBs and the LEDs and whatnot. So all in all, really happy with the build. Looks really good. And if you got any questions or, you know, want to discuss in the comments down below, feel free to ask. I always read every single comment. And I try to reply to most of them if they're legit questions. You know, whatever. So if you like this video, make sure you hit that like button. And if you want to see more builds in the future, hardware reviews or whatever, consider subscribing. As always, my name is Stan, and I'll see you guys in the next one.